Hi, my name is Angel Boo, and I'm a rising senior at the University of Florida. This is my lightning talk on my project, Optimizing a Neuromuscular Model. My direct research supervisor was Robin, and my PI was Dr. Hugh Herr at the MIT Media Lab Group, Biomechatronics. The work that I performed this summer is all based on David Hill's thesis that a neuromuscular model can be characterized under Hill-type contraction dynamics, and you can apply these kinematics or angles, these joint angles, and muscle activations to produce a joint torque. This concept is then applied onto a musculoskeletal model, which could be used to power a prosthesis controller, which is the exact intent that me and Robin intended to do, and that you apply these ankle-knee angle geometries along with the specific gastrocnemius, soleus, and tibialis anterior musculotendon specific parameters into a Hill-type contraction model. And then this backs out the max isometric forces as well as the optimal fiber length and tendon slack length applied into a reflex and stimac block to give us a predicted torque. All the data backs out from a pipeline in which motion capture data is collected through Vicon. This is then used to scale the model based off of static markers from Vicon. This allows the 3D musculoskeletal model to have near perfect proportions to the actual person's proportions. Inverse kinematics is then applied to determine the joint angles from a specific trial or a marker set, motion capture marker set. As you can see in the video above, this is actually from a patient's walking trial. Applying the ground reaction forces collected from force plates and the kinematic data, you can actually use OpenSim to determine specific muscle parameters through muscle analysis. This would give us the input for the musculoskeletal model that would be applied to the prosthesis. So as I said before, you can back out all the inputs to then get a predicted torque. These would have been the predicted results if we could finish the pipeline, in which we would see a torque curve and a torque against time curve in both the anterior posterior directions. This could be seen through the regular dorsiflexion, plantar flexion angle. And then the lateral medial direction, you could actually notice from the subtalar angle direction. Future implications for the research. At the moment, there is no current 2 degree of freedom prosthesis in the market. I feel like this research could definitely be used and applied onto an existing model in which we are creating, along with the use of AMI, or an agonist-antagonist myoneural interface, which allows the amputee to regain proprioception. It will allow for a more seamless prosthesis connection. Thank you for listening to my lightning talk.